Hello students, welcome to Spectra Education Academy. In this video, I am continuing the explanation for short answer type questions from the chapter Wave Optics. Let us continue. Question number 3. Derive the expression for the intensity at a point where interference of light takes place or occurs. Arrive at the conditions of maximum and zero intensity. So this is a question related to Young's double slit experiment. So take here is the source. Here is the source. Here is the source. And it is sending waves in all directions. So take a screen here. Take a screen here. You give two slits which are at equal distance from the source. Let us say slits. This is first slit. This is second slit. And so these two slits are at equal distances from the sources. And take another slit. Take another slit. Once the waves are incident on both the slits, so waves are coming out of the two slits like this. Say this interference takes place at a particular point. At a particular point P on the screen B. So let's say this is screen A. So there is a chance of forming bright band or there is a chance of forming dark band here at point P. So let us discuss. So capital D is the distance. Capital D is the distance between the two screens. Capital D is the distance between the two screens. So this is capital D. And small d is the distance. Small d is the distance between the two slits. Let us say this is small d. Yeah. A central bright band is formed here. Around the central bright, there is formation of dark band. Around the dark band, there is again formation of bright. Again around bright, there is dark. So continuous dark and bright bands appear on the screen due to interference. So in the previous question, we discussed that there is no loss, there is no gain when interference takes place. So there is a chance here. There is a chance here to get a bright band here. Yeah. So this is how picture appears on the screen B. Now let us see, there are two sources in the form of two slits. Two slits are made. You can say two slits are made to screen to screen A, which are at equal distances, from the source, S. They emit waves of equal wavelength and amplitude. And there is another slit B. It is at a capital D, distance capital D from the slit A. So there is another slit B at a distance capital D from the screen A. Another screen you call it as, not slit. So there is another screen at distance capital D from the first screen. So small d is the distance, is the distance. Small d is the distance, is the distance between the two slits of the first screen. Between the two slits. Two slits of screen A. Screen A. Now, so there is path difference, there is phase difference between the two waves. Say delta x is a path difference. Path difference between two waves. Two waves. And delta pi is the phase difference. Phase difference between the two waves until they reach point P on the screen B. Now let us concentrate on the equation part. Displacement of the first wave. Displacement of the first wave y1 equal to, it is A sine omega t. Let us say A1 is the amplitude. Afterwards we make them equal. A1 sine omega t for the first wave, and y2, because there is phase difference between the two waves, y2 equal to A2 sine omega t plus pi. So interference is mainly because of superposition of the two waves on the screen. So according to superposition principle, according to superposition principle, according to superposition principle, net displacement or resultant displacement y is equal to y1 plus y2. This can be written as A1 sine omega t plus A2 sine omega t plus pi. Now, so you split this one. So we can make A1 equal to A2. We can make initially A1 equal to, because we said in the definition A1 equal to A2. So therefore, if you take common A, so this is going to be sine omega t. Here itself you split sine as sine A plus B. Use sine A plus B. Sine A is omega t, sine omega t cos pi plus cos omega t sin pi. Now, yeah, let us continue. A sin omega t plus A sin omega t cos pi plus A cos omega t sin pi. So this is all equal to resultant displacement. Now, take A sin omega t from these two, take A sin omega t common. A sin omega t common, you'll get 1 plus cos pi. Just you write this equation as it is, A cos omega t sin pi. Now treat A of 1 plus cos pi, A of 1 plus cos pi as A cos theta. Similarly, A sin pi as A sin theta. So let us call this equation 2, let us call this equation 1. Squaring and adding of both equations. So first let us concentrate on this one. So directly I am writing it. A 1 plus cos pi. 1 plus cos pi. This is squaring. So squaring, taking the left side terms on one side. A sin pi whole square is equal to A cos theta whole square. Squaring and adding. Squaring both sides and adding. And adding. So you are adding, you are squaring and you are adding the right side terms. A sin theta whole square. So now a square 1 because a plus b whole square cos square pi plus 2 into 1 cos pi plus a square sin square pi right side a square cos square theta a square sin square theta. So this is going to be a square, there is cos square theta, sin square theta, you can take out common cos square theta, cos square pi, sin square pi, plus 2a square cos pi, right side, a square common, cos square theta, sin square. So therefore this is trigonometry identity, this is also trigonometry identity, so their values are 1. So now we'll write that a square plus a square you'll get. So this is going to be 2a square. There is another 2a square cos pi. Then right side we have a square. If you take common here, 2a square, you will get 1 plus cos pi is equal to a square. So we all know that 2 cos square theta is equal to 1 plus 2 cos square theta by 2 in particular. 2 cos square, since we have written letter pi, 2 cos square pi can be written, 2 cos square pi by 2 can be written as 1 plus cos pi. So let us substitute that. 2a square into 2 cos square pi by 2 is equal to a square. Now, so it is altogether 4a square cos square pi by 2 is equal to a square. So we know that intensity of the wave is directly proportional to square of the amplitude. Let us say this is the intensity of the resultant wave is directly proportional to amplitude of the resultant wave. Similarly, intensity of the incident before they interfere on the screen is directly proportional to square of the amplitude. Now let us incorporate here. I resultant equal to, because this is resultant amplitude, then 4 I naught cos square pi by 2. So this is the desired equation. Now let us get the conditions of maximum and zero intensity on the screen. Suppose if pi is the phase difference, particularly for zero intensity. So we all know that cos at zero angle is maximum, 180 is also maximum, even 360 is maximum. So let us attain like that. So conditions for zero intensity. For maximum intensity, let us begin with condition for maximum intensity. Maximum intensity. So constructive interference forms. If you assume pi equal to 0 first. So 0 means cos square 0. So it will be 1. If you assume here 2 pi. 2 pi means, so cos square 2 pi by 2. So there is a chance for you to get 180 degrees, cos 180 is minus 1, but there is squaring. So therefore again it will become positive. Similarly 4 pi, so on. So you can extend this up to 2n pi, treating n equal to 0, 1. So if you put 0, you'll get first case. If you put 1, you'll get second case, so on. So to get maximum intensity on the screen, phase difference must be extended up to 2n pi. Condition for minimum intensity. Condition for minimum intensity. Minimum intensity. Assume pi as a pi, which means cos square, in place of pi you are writing pi radians by 2. So it will be 0, 90. Similarly 3 pi. Similarly 5 pi. So this can be extended up to 2n plus 1 outside pi by 2. Suppose if you write pi only, because in place of pi, n equal to 0 if you put, n equal to 0 if you put, you will get pi. N equal to 1 if you put, you will get 3 pi. So this is where you will get minimum intensity, destructive interference forms, dark bands appear on the screen. So this is how you need to represent the answer in the exam. Now let us continue the next question. Yeah, next question is, explain Doppler effect in light. Distinguish between redshift and blue shift. So this is very much similar to define Doppler effect in light. Explain redshift, blue shift. What is its importance? Yeah, so this is very much similar. Yeah, first let us write what is Doppler effect. So when the source of light, when the source of light, when the source of light moves away, moves away or towards an observer, it appears that it appears that when it moves away, when it moves away, wavelength increases, frequency decreases. When it moves towards the observer, wavelength decreases, frequency increases. So it appears that increase of wavelength, increase of wavelength. So when you say increase of wavelength, there is decrease of frequency. Speed of light remains constant. So wavelength increases. It appears as increase of wavelength when you move away, or when you move towards decrease of wavelength. Or else, when you say increase of wavelength, there is decrease of frequency. When you say decrease of wavelength, there is increase of frequency. So finally, the apparent change in the wavelength, or you can say frequency, apparent change. So it appears only, does not occur really. The apparent change in the wavelength or frequency, apparent change in the wavelength and frequency of source of light due to relative motion, between the source of light and observer, due to relative motion between source of light and observer, is called Doppler effect in light. Right. So let us continue. So the change in the frequency, delta nu by nu, or you can say delta f by f, is equal to v radial. So this is speed at radial divided by c. This is speed of light in vacuum. Now, let us continue. What is red shift and blue shift? So we all know that wavelength of red is maximum. So when do you get maximum wavelength? Means when source of light goes away. When source of light is moving away from the stationary observer, it appears that wavelength increases. Wavelength increases. This increase in wavelength is close to the wavelength of the red in the spectral series, in the spectral line. and spectral line shifts towards red. When wavelength increases, spectral line shifts towards red. This is called redshift. Similarly, exactly contrast to red, blue shift. When source of light, when source of light is moving towards the stationary observer, it appears that wavelength decreases and spectral line shifts towards blue in the spectrum. This is called blue shift. Blue shift. So this is how you need to represent. Now let us continue with the another question. Explain polarization by, yeah, explain polarization. This is not there at present. Now let us continue. Discuss the intensity of transmitted light when polaroid sheet rotated between the two crossed polarides. Yeah. Let us continue. Explain polarization. Sorry. Discuss the intensity of transmitted light when polaroid sheets is rotated between two crossed polarides. Okay. So take three polarides. This is the first polaroid. The first polaroid called this as a P1. Transmission axis is this one. Second polaroid is this one. So compared to the transmission axis of first one, let us say this is going to be the transmission axis of the second one. Now angle between the transmission axis of first and second, we call it as this is theta. Now similarly, you draw third polaroid. This is polaroid P2 and third polaroid. So the transmission angle between the transmission, this is the second one. Let us say this is transmission axis of the second one. In compare, this is now this is transmission axis of the second one, this one. But the transmission axis of third one is this. So which means angle between these two is pi by 2 minus theta, 90 minus theta, otherwise you can call it as. So this is the transmission axis of the third. This is the transmission axis of the second. But angle between the transmission axis of the first and second is theta. Angle between this is transmission axis of the second. Angle between the transmission axis of the second and third is 90 minus theta. Now when unpolarized light is starting from here, unpolarized light is starting from here. It is incident. Let us say there is I naught here. I naught is the intensity of the polarized light when it passes from polaroid P1. And according to Malus law, so we can say I dash is equal to I naught cos square theta. So this is the intensity of light when it coming out of the second polaroid. Now coming to light is coming out also to third polaroid. So therefore I double dash, let us write it as I dash cos square 90 minus theta. So what is I dash here? I dash is I naught cos square theta. Along with that, there is cos square 90 minus theta. So therefore, so the intensity of light which is coming out of the third polaroid will be like this. You can extend this. I naught cos square theta. Cos 90 minus theta is sin theta. Since there is square, you can say this is sin square theta. Even we can also express in terms of sin 2 theta, multiplying and dividing with 4. So therefore, so we can write this is I naught so we can write that you split this 4 as 2 into 2. 2 you take 1 cos theta from this, cos theta and sin theta, 1 sin theta from this, and there is 2 more here, cos theta and sin theta, whole divided by 4. So this we can write it as I naught. This is 1 2 sin theta cos theta, another 2 sin theta cos theta. 2 sin theta cos theta. Also there is 2 sin theta cos theta. Whole divided by 4. So we get the expression as I naught sin square 2 theta divided by 4 is equal to I double dash. So when theta is pi by 4 means 45 degrees. So intensity will be maximum, which is coming out of the third polaroid. Yeah. Let us write some points related to the diagram. So that is, consider polaroids, 3 polaroids P1, P2, P3. Consider 3 polaroids P1, P2, P3. Let I naught be the intensity of light while passing through the first polaroid and when it passes, because there is angle between two transmission axes is theta, let us include that. I dash be the intensity of polarizing light while passing through second polaroid, that is intensity of light while passing through second polaroid, that is I naught cos square theta. And finally, this passes through third polaroid. So it will be I double dash, I dash cos square theta minus 90 minus theta, because angle between the transmission axis of polaroid 2 and 3 is 90 minus theta. So therefore, we get that I naught cos square theta and cos square 90 minus theta, because I dash is replaced with I naught cos square theta. This part is appears as sin square theta. Thank you very much, students, for watching my video. I'll continue explanation for SAQs in the next chapter. Thank you very much for watching. But don't forget to share and subscribe with your friends and relatives.